So now we have the talk on the radio and what happened to it. If you've been to the Congress, you're already familiar with software-defined radio and the great Munich CCC team that organized it. We have Zach and Schneider here, who are members and also founders of the CCC Munich and organized the radio at the camp. Thank you.
All right, hello everyone. Welcome to Radio++, radio half a year later. The radio in half a year, I mean, a lot can happen and we'll cover stuff. So, what is the radio? The radio was the electronic name badge of this year's Chaos Communication Camp, and statistics say that around 50% of the people in this room probably haven't been to the camp. And we wanted to make something special for camp, and it's a multi-role SDR badge. That means it's a software-defined radio, but also a badge. We made it compatible to the HackerF, which some of you might know. It's a very popular open source SDR platform from Michael Osman. We took a lot of his designs and made it into a badge. It's not only an SDR, it's also a development platform. It has a dual-core CPU on it, also 2 USB ports with host support, which I think is quite nice to play with. So why did we do that thing? 4 years ago, we did Rocket, also an electronic name badge for Chaos Communication Camp 2011, and that thing was a blast. We had a lot of fun doing it. It was very stressful, but also very rewarding. Lots of people did very nice projects with it, and 4 years later, it was almost not a question anymore, do we want to do it, but rather, what do we want to do? And that gets tricky. I mean, you don't want to stand still, and really the goal of the Rocket in the beginning was to have something reusable that people use afterwards and also learn something. So not just an Arduino, but something where you can actually have fun with, discover something new, and 4 years ago that was an ARM processor. So why an SDR? Well, basically, we were into SDRs roughly 1 year ago, and we thought that would be a nice thing to have on a badge. It's not like some sensor we put on there and 1.5 years later, the next Samsung, whatever smartphone has that thing already on there, but it's something which will be not available to the general public or cheaply available for quite some time, and we wanted to make that stuff available for people to play. SDR, sounds nice, also complicated, but interesting. Why would you want to have an SDR? Because lots of stuff is wireless today. And wireless stuff pops up on your doorstep, potentially, as a smart meter or something different, and there's no way you can have a look at that. But with an SDR, you can. You can probe that stuff, you can interact with that stuff, you can learn more things. And roughly 1.5 years ago, Zach and me, we started looking at satellites, we got into SDR, and we lost our fear about SDR, basically. And that's one of these myths. SDR, it's not hard. I mean, you can make it hard if you want to, but you don't have to. If you have enough time and motivation, you can get it done. And you need like 3 math functions. You need sine, cosine, and Pythagoras, and then you can figure things out. Basically, you can think of SDR as the science of a point moving in a plane and figuring out how it moves in that plane. That's at least how we, in the end, understood SDR, and that's what we have here. There's a picture there. It has lots of points. They move in circles, and the circle moves in a circle. And what it means is that you have some frequency which is modulating an offset from your center. Basically, you follow the point on the plane and apply some math to it. We won't get into SDR too much for this talk because we're focusing a little bit on the radio. There's a Datengarten talk of me in German, actually, which I held at CCCB. You can find it on media.ccc.de, which explains a little bit of stuff. And Michael Osman, he has great videos for the HackerF tutorials about SDR. Check them out. You will not have a problem afterwards. So, where can you get a radio? Well, half a year ago we told you, well, maybe we'll build some more, but really no one has stepped up, no one has the time, and it's unlikely that will change. But it's an open source project after all. The Eagle files are on GitHub. The original files for the HackerF are in KiCad. We had to somehow speed things up. We were familiar in Eagle, so it's Eagle files. Sorry for that. But nevertheless, a free viewer and the Gerber files will be there. So one of our prototype manufacturers agreed to step up and accept orders for the radio, ideally in bulk. We'll have contact details at the end of the talk and some idea about how to manage that. Table of contents. Now, let's get into it. We'll cover firmware changes in half a year. We'll cover what happened to the hardware, and you wouldn't imagine how much can happen to hardware in half a year. We'll look back on the radio challenge at the camp, where we had an SDR challenge. We'll talk a little bit about the nice art project involving the radio and the lounge, and then a little bit about SDR, some resources, and final words. Now, Zach is our firmware guru. He did a lot of stuff, a lot of magic to get all of this bootloader stuff and switching between different parts of the RAM going, and he will cover the firmware part.
Thank you. So the firmware was not only my doing, I had lots of help from other people of the Munich CCC. And we will not be going into all details. We just want to show you what's the current state of the firmware. So the firmware is, as at the camp, still on GitHub. There have been quite a few changes. Several people have sent in pull requests, and most of them have been merged. We might have missed something. If we missed something, just maybe contact us again and we will look at it. It's always right after events. We are a little bit busy with all the requests and it might drop something on the floor. I'm sorry for that. But it's still open for everyone. The current firmware, I don't know, I mean, half of you were probably not at the camp, has different concepts. There's the camp firmware, the one that shows your nickname and runs stuff. And this one loads small modules that are called laudables, which is a self-contained small binary that you can run inside the normal camp application. We had quite a list of laudables in the meantime, many of them submitted by different people. And we will just do a quick overview of what we've got now to maybe get you in the mood of writing some code for the radio yourself. It's not that difficult. So the first one is called B, which is a re-implementation of a fairly famous web game. I mean, doesn't look like the best strategy here. Well, okay, so you can play, and of course the display space is limited, so after like 9 it goes to A and B, and if you reach B, you're done. That's why it has this name. So the next loadable is Snake. That's a re-implementation of the old Nokia Snake game, so we need to be compatible to old phones. And because he ran into the wall, there's also Snake 2, where you can wait for it. The suspense. Yay! Okay. That makes it much more difficult to kill yourself, as you can see right there. Then we have Tetris, which we sped up a little bit because the start of Tetris is quite boring. No one of us can play that fast. Okay, but that's all games. And the next one is also a game. I mean, that's the simplest thing. That's actually a port of the laudable, which we also had for the Rocket 4 years ago, just with some added colors. there was, I mean, oh, you didn't get the UFO. Okay, the next thing is bricks, which is a submission we got. I mean, looks also familiar. Well. Okay, might need some improvement. Then there is also nice graphics hacks, like the cube, which I particularly like. Just nice to look at, and Mandelbrot, which is actually also a port of an old laudable for the rocket. You can zoom in quite far. Then we have the fire laudable, and I think the last thing is wobble, yes. I didn't think of those names, those are submissions. But you can see that the CPU is quite fast to do this stuff. Then there's always the question, how much space is on my radio left? We have a 2 megabyte flash, which has 1.5 megabytes for the file system to put all the stuff on it. And you can also see a nice graph of how much space is still left. Then we have the schedule laudable, which is done by Ray, which has a small schedule of the current 32C3. You can get it at our wiki, or if you stop by our assembly and flash your radio at the flash station, then you have the schedule, and if the servers are down again, then you can just look it up on your radio. So the next laudable is, no, there's no more laudable, sorry. The next, those are actually also laudables. I mean, the idle animation of your radio shows your nickname and maybe some animations. They just have a special name and display your nickname. This is Live, which has the Conway game of Life in the background going. Then we also have the Matrix laudable animation, which shows you the thing. Then some nice stars in the background. And this is also a submission. I rather like the fact that it's running very smoothly. And the last one is using the full color capability of our display, which is the color plasm. There's also like the basic ones that just show your nick and do nothing, but those are not as interesting. And then this concludes the list of laudables, which run inside the CAMP firmware and can use all the framework of the CAMP, all the functions that are already implemented. You can write a complete application which runs standalone on the radio and has nothing to do. To enter the menu for that is if you turn it on, you hold the joystick to the left, and then you get a list of the applications. The most common ones are the CAMP application, which shows your nickname and stuff, and the HackerF, which is by now replaced by the HackerF app application, which does the HackerF compatibility. I mean, you have it as a SDR, which you can use with your computer with GNU Radio, and it's compatible to the HackerF. There we have also some other applications, like a submitted one that plays mod files. There we have a demo.
Yes. 1 second.
Just a second. Thank you. That was rather nice. I mean, you need to plug in a headphone for this. And then we also have the RF app, which does some standalone RF things, like a waterfall display where you can see, you can set the frequency which it shows, and then it shows you if there's activity there or not. You can also select the speed up to how fast the CPU will allow you to go. And it has a bandwidth of 2 megahertz, which is not too bad for a standalone thing. The RF app also has some additional features like a FM receiver transmitter, which we want to demo right now. Just a second.
Okay, this thing is a wideband FM receiver and transmitter submitted by Hilse. So you can select the frequency you want to send on or receive on. It has push to talk. If you press the button inside this application, your badge basically merges into an FM transmitter, and we're now tuning to 2.4 gigahertz on our badges, and we'll transmit audio from Zach's badge to my badge. I'm running the receiver, he's running the transmitter. It's basically, it's the same software, you just have to make it a transmitter. Let's see if it works.
Hello? Test?
No?
Success.
Try again.
Oh.
I think we...
I cannot hold three things at once.
Hello? Get away a little bit.
Test, test. Oh, yes. Hello, test. Yay! Crappy quality, but...
Okay, I guess that was a little bit of overpowering the receiver, but in fact, if you tune to a wideband FM broadcast station, it has very good quality. Also,
you might need to have an antenna appropriate for the frequency. The built-in antenna is only tuned for around 2.4 gigahertz, and radio is quite a little bit lower than that. And thanks to Ed Hilse, who wrote this application. He really went into the RF stuff and implemented all the necessary functions for that. We wouldn't have had the time to do it in as nice fashion as he did. Yeah, I told you a little bit before about the HackerF app. I mean, before at the camp, you could start it in HackerF mode and it would work like a HackerF, but you would not see anything on the display and would not get any feedback from the application what you do. Now we have the full GUI experience where you can actually see what the badge is doing. I mean, this is when you start it, it's off, and then you can, if you receive something from your computer, then the display shows that you are receiving. Ah, yeah. Next slide. And you can also see the settings if the amplifier is enabled or disabled, or the gain settings and at which rate you is receiving. Because we found the HackerF tools sometimes confusing to not. I mean, if you don't set anything, it just leaves the last set mode for like the amplifier. And that might be confusing, and so you can see at a glance if it's on or not. And then if you transmit, it shows you that you are transmitting, and you get the full feedback. There's nothing to select on the badge, but at least you get a nice display. And last but not least, just a few days ago, again at Hilse submitted the RF lib, which does several RF-related stuff in a nice library where you have quite easy functions to set the frequency and run binary frequency shift keying to transmit data or receive data. It even uses offloads some of the processing to the second core on the badge, so you can run other code on in the meantime, while you receive stuff on the main CPU. That works really great. The only caveat is that if you want to send something to the display, you need the special function from the library so the display is set up correctly and does not conflict with the RF code in the meantime. But that is really great and has part of the GitHub since 3 days ago. Last minute edition, but it's really great. And what we still plan to do, what we haven't gotten around to, is we want to upstream the changes we made in the radio to the HackerF GitHub, so we don't have to maintain them separately, and we can also always be up to date with any other changes that happen upstream. And one project that Schneider still wants to do is to send and receive stuff directly from the SD card. That is not populated by default, but you can solder an SD card slot on your badge, and then from the firmware read and write files. And you could, in theory, this is what we want to do, just receive something and write it to the SD card, and then replay it from the SD card. So you would have a standalone RF replay device, which might be nice if you have like old garage door openers or something like that. Now we come to the hardware details, and I have to defer that to Schneider because he's the hardware guru.
All right. Thanks. So, what can happen in half a year to hardware, you might ask? Well, bugs. You can find a lot of bugs in half a year in something you've cobbled together in 2 months, and we found plenty of them. Some of them you can fix in software, some of them you can't, and we'll go through all of them right now, all of those we know about, and tell you if you can do something in software, if you can do something yourself, or if it's just like that now. Okay, so one of the common problems also of the HackerF is that you can get lots of interferences from clock lines which are on the PCB itself, and they manifest as peaks in the spectrum. These are inherent to the design. You can't really get rid of them. If you have a clock at 40 megahertz somewhere on that device, you will have peaks at 80, 120, 160 megahertz, and they won't go away. Thankfully, if you have, for example, a clock at 40 megahertz, you can see here there's a big peak at 80 megahertz. That's the first harmonic there. And if you go up in frequency at 120, it's a bit lower, 160, even lower, 200 gets a little bit lower, and at roughly 400 and above, you can't see that anymore. But it means that's something you have to live with. If you see these peaks in the spectrum and they're there, they don't move. Whatever you do, you attach the antenna, you remove the antenna, they're there, you have to ignore them. And there's only a limited amount of stuff we can do. We did a little bit. We'll cover that later on in the talk, but just as a heads up, be aware. All right, next one. Missing high pass. So we announced the radio as being workable from lower frequencies, roughly 10 to 30 megahertz, up to 4 gigahertz. But we didn't populate one key part for the 4 gigahertz operation, and that's a high-pass filter. We had to save cost. That thing was going to throw us out of budget, and we left it out. But the result is that you can't transmit or receive above 2.75 gigahertz. We originally thought that we can solve that in software, but now realize that's not possible. There's only two solutions. Either you populate the high-pass yourself, you can get the part number from the schematic, no problem, or you just bridge it. But be aware, if you bridge it and you transmit something, you really have to add an external filter to remove some of the harmonics created by this, because there's a reason this thing was on there in the first place. If you just want to receive above 2.75 gigahertz, should be okay to just bridge that thing. And we have reports of the backlight staying on. And that's caused by a design decision which we took, where we placed the pin which controls the backlight onto a pin which also controls the boot options of the MCU. It's high by default, and if you turn it off, it's floating a little bit, but high. And on some badges, it turns on the display even when off. Tricky to solve. The only real solution to this is to unplug your battery. Otherwise, it will drain your battery and at some point will just be empty. Yeah. Next one. Antenna. Originally, the antenna was designed to be at around 2.4-ish and a little bit up, so 2.48, 2.5. because there's a bit of space where there's no Wi-Fi, and it would be nice to have the radio transmit and receive there the best, because that gives the best batch-to-batch communication. But turns out that we mistuned it a little bit. It's too low. It's at 2.35 gigahertz. Works well still at 2.4, 2.5 gigahertz, but not the best. Sadly, nothing we can do about that either. USB power. Now, we have 2 USB ports on there, and they're current limited. Also, the first USB port takes precedence. So if you plug in the first USB port, it will always take as much power as it can from that thing to get powered. If you attach the radio to a Raspberry Pi, that can be a problem, because the thing can't supply enough power anymore. You cannot supply it at the same time for the second USB port, because that thing doesn't take precedence and is also limited to 0.5 ampere, which is not enough to supply the radio. There's 2 solutions to that. Either you take some Y adapter, which basically takes power from some other part, or a USB hub which is powered, which is basically that. Or the HackerF firmware gets ported to the second USB port, and you can power it for the first port and have data coming off of the second port. This hasn't been done yet, but just be aware, if you attach this thing to an embedded device, might take too much power. Then, the clock input. We initially thought that around 1/3 of all radios have a working clock input, or at least could be made workable. But turns out that during the design, we hardwired that clock input to ground. There's no way you can fix this. It looks easy on the picture here. Just remove that, that piece of copper which connects the pin to the ground plane, but it's below the chip, and you won't reach that. So the only way to introduce an external clock into the radio is really to attach it, solder it to the pads of the crystal, and supply it with 27 megahertz. No way around that. And the ISP pin floating. We missed a pull-up. We've seen it once. Someone soldered something to a connector on the radio, didn't boot up anymore. There's a pin on the microcontroller called ISP. It's floating. And if it goes low, the thing doesn't boot. So if you have something like that, that's really rare. So far, we've seen it once in Munich. It seems to be no problem as long as you don't solder on any connectors to any connector which has the ISP pin on. Check the data sheet and the schematics for that. Something similar, reset pin. We've seen it's a little bit touchy. If you put anything onto the reset pin, make sure that that thing still gets pulled high. We've seen radios reset occasionally if something is happening there. Next one. So, typical problems. Now we get into stuff we can actually fix. Broken display. Well, look for Nokia 6100 displays on eBay. They're available, not that expensive. We also have some at the radio assembly right now. I think we have 40 with us. If you have a broken display, just step by and we can swap that thing out. And because someone told it to us, you can't use a rocket display. They're pin incompatible, and if you think you move that on, I'm surprised that the thing doesn't go up in smoke. So please don't do that. Next one, no audio input-output. The headphone connector sometimes isn't soldered properly. Check that. Check the pins on the headphone connector. Solder them again to make sure you have contact, and sometimes you also have to rotate the headset a little bit, like the actual connector of the headset to make contact. We've seen that also. Yes. Bad power switch. It's like the most stressed part of the rocket. If it fails, remove it, put a jumper on there. That's fine. No data flowing. We've seen that. You go into HackerF mode. It's detected, everything works, you can set the settings. Even the HackerF app, which we've wrote, shows stuff, but there's no data flowing. That's potentially because of a bad USB cable, too long USB cable, not enough power getting in. The display flickering, please charge your battery. That's the low battery indication. Actually, it's the protection circuit, which is a little bit, it's not very steep, so it starts to flicker when the voltage goes down. Nothing to worry, just charge your radio. Then if you mount the thing, mount internal flash memory onto your PC, it takes a very long time to write something to the flash memory. That's normal. Please use the safe eject feature of your operating system or type sync into a console on Linux and press enter and wait until it returns. That way you make sure that you don't corrupt your data, your file system, and everything will be on there. Just, you have to be very patient. It can take a few minutes to transfer large amounts of data to the radio. Then, RGB LEDs. We made a mistake in the layout. The transistors which should turn on the power or off the power aren't populated correctly. And then we had some mishap in the communication with you guys. So really, it's not necessary to run any wires or anything across the batch. Just bridge 2 pads at every transistor, and you will be good to go. No special hacks necessary. The antenna connector. If you solder on a connector to the antenna, make sure that you don't bridge the 2 pads which are in this circle. They're very close together. They're not connected by default, and they're easily to bridge. And if you bridge them, you bridge the power supply to ground. The thing won't do anything anymore. It will just get very hot. Sadly, there's no solder mask in there, I think, and they're very, very close together. It looked like huge distance while layouting that thing, but really it's very small and really easy to bridge. Make sure you don't bridge these 2 things. Also, if you're solder in a BIST, you might have an active antenna like GPS antennas or modified GPS antennas, for example, that we use for Iridium and other stuff which have amplifiers in the antenna. You can add a small coil in there, like 10 microhenries, for example, for a GPS antenna, and that will power the antenna. Also make sure that you don't bridge the pads there. And while the HackerF has this thing as default, built in and also switchable via software, we neither had the time nor the money to implement it, but if you want that, it's really big pads. You can solder in a rather large inductor there. Yeah, just get it done by someone, do it yourself, should be fine. One very important thing, if your antenna has a DC path, and that means an electrical path from the inner conductor of the SMA connector to the outer conductor, that thing might burn out the inductor. For example, this log periodic that we show here, that we used to capture some Iridium stuff, has at the very end a small connection connecting the 2 parts of the antenna. Make sure you don't do that. Okay, protection. There are some very tiny parts on the radio, and they get off easily. We really recommend you solder on some shields or get some case for the radio, because they break off easily. We have a few of them now, or at least take a lot of care when transporting the radio. Wrap it into something, make sure there's nothing scraping on the PCB. Then, performance improvements. We've improved the firmware quite a lot. You can see here in the middle, there's the signal where it should be, and on the sides, there's huge mountains of unwanted spurs and energy, which should not be there. We did some improvements to the PLL, and now it looks a little bit different, like this. Really, this improves transmission and reception a lot, and I urge you, update your firmware. If you do anything with the SDR on the radio badge, it's a lot better now. Same thing for the spurs. We disabled a few clocks, which most likely no one uses at the moment anyways. We've removed one clock. We've moved one to another clock so that we don't get additional spurs. That's improving the reception a lot. Again, please update your firmware. Next thing. So, radio challenge. We had a radio challenge at the camp, and Zach is going to talk a little bit about that.
So, at camp, when we gave out all these badges, we had a problem that we wanted people to play with SDR. There's this misconception about SDR that it is difficult and obscure, and people tend to say, oh yeah, that looks difficult, I don't want to touch it. And we wanted to get people to try out all the SDR features of the badge. So we ran a radio challenge where we wanted to have some, invite the people to play with the radio, and at the same time, I mean, have clear defined things they could do, and we wanted to have them, I mean, all at the same time trying stuff. So we implemented the radio challenge. We wanted to ramp up the difficulty, start with very easy problems and slowly increase the difficulty. We didn't want to have really difficult things. We wanted to get people to introduce them. We were very short on time because we also had to finish the radio before camp and then give them out to people and give support for problems. And so we only managed 9 challenges. One of them had to be removed because there was some miscommunication and all the possible answers were wrong. So actually it were only 8 challenges. And we got some room from the Munich CCC to have a web interface for solution tracking where you could register and put your solutions in. That made it easy for us to at the end to check who had the most correct answers. Then we have, I have a quick overview about the challenges for you. I mean, the first one was just flash some code on it. This is like a really low barrier of entry, so people have to like look at your badge and find out how to start it and run some code on it. And maybe if they see that it's not that difficult, maybe they even develop some loadables or something later on. The second challenge was a waterfall challenge. There was a hidden transmitter somewhere which transmitted a signal which was turning on and off at certain intervals, and the answer was just how much time passes between two times when the signal is on. So this gets the people to install a simple waterfall tools or just turn it on and play with it. The second one was like only slightly more difficult to find where in the frequency of a signal is. We told them it is somewhere between, I think, 1 gigahertz and 1.5 gigahertz. And then you have to just use GQRX or any waterfall diagram and find it. We had improved the difficulty a little bit for the next one. And we had an FM transmitter, which was transmitting some self-recorded stuff. The RF app at this point did not exist, so it was not just starting the RF app, but you had to install some SDR tools and do some FM receive, or you can do it with GQRX, which does it built in, but still you need to familiarize yourself with the tools. Then, just because we are at camp and we wanted to get people moving around a bit, we hid one transmitter somewhere and people had to locate it. The first challenge was somewhere near our village, because it is fun to see people running around in your village and searching for something. And then this was concluded the most of the easy challenges, and we wanted to have a little bit of difficulty at the end. This is the H22262 is the remote controlled power sockets, the really cheap ones. We had the remote control for one of them at our village, and people had to decode the address that it was sending. It's not that difficult. We had some introduction in the question, and we had an SDR workshop where we discussed this in case you wanted some help. But many people managed to do this. You can also do it just by looking at a waterfall diagram that is really is fast enough to catch the signal. If you just want the easy way. And the last 2 challenges was the same remote control power sockets, but you had to turn one of the sockets on. That might have been too difficult, or we fucked something up because nearly no one got it correct. I think we had one contestant who got it correct, so I'm sorry for that. I thought it would be easy enough. And the last one was just for fun, was again, locate a signal source, and this time it sent something in Morse code, and you needed to also decode the Morse code. There was we hit that at some other village, and at the end, when we wanted to grab it, we knew where we hid it, but it wasn't there anymore. So the plus point is when you give all the people on the camp a radio, everyone has a radio. So we just grabbed the next person and asked them to borrow us their laptop and their radio. And so we started to search for it and found out it's surprisingly difficult without a directional antenna to actually find this thing. The successful strategy was having several people around standing in the way and blocking the signal to make a human directional antenna. Yeah, and at the end, we just asked. They had a lost and found bin at this village, and it was in there. So we had really fun to make this challenge, and the feedback we got was really positive. Unfortunately, not that many people took part, so we wanted to revive this challenge for the camp, for the Congress. We still haven't set up anything, but stop by our assembly later, and we might have put up a few of the challenges again, just if you want to play with it. And there is one more thing. We have some Me lights, which are remote-controlled light bulbs. Turn it on. You have with an RGB LED. They're not that expensive and use either the normal, both normal light sockets. I forgot the names of those. And if the first standalone radio application that someone writes to which remote controls one of those, the protocol is not that difficult and Googleable. I mean, the first one who stops by our assembly and shows a standalone application on the radio gets 2 of those lamps. He doesn't need a remote control. Yeah. So this concludes the part of the radio challenge, and now we come to the launch licht.
Yeah. Okay, so this is an art installation in the lounge. Ans and Chris from the Munich CCC did it. It's basically just a radio connected to DMX of the lounge, which has the light information of all these installations. Transmitted over radio to the other badges, and they can receive that and switch on their LEDs like the lounge wants it or the VJ wants it. It's pretty easy. There's a small protocol. You can set all LEDs, you can set them off to the same color, to different colors. And we have small piece of hardware. It's just black box, radio strapped to it, small power amplifier. It goes up onto some antenna in the lounge, and you can receive the signal there. And there's a small application. It shows your nickname, and when you get near to the lounge, it starts to blink the LEDs, change the background color of the display, and so you can be part of the light show at the lounge. This is based on the RF flip von Hilse. Oh yeah, you should have some LEDs, but we have lots of LEDs at the assembly, so if you need some, just get to us. We have a flash station at the assembly. You can get the latest firmware there, including the launch app. And otherwise, you can get it from GitHub, just compile it yourself. We'll have some binary distribution later on today, I think. Now, SDR. This is going to be very short. What can you do with SDR? There's some recent hacks here. I mean, of course, what we did, the Iridium stuff. There's also global stuffing, so that's satellites. There was a really nice Zigbee hack lately, using very weak encryption or known keys of the Zigbee protocol to open locks and stuff like that. Have a look at that, play around with that stuff. Public transport, maybe you want to receive your local schedule for public transport, you can use the radio for that. There's quite a few different hacks. Go to Hackaday, get the SDR tag on Hackaday, and you'll find lots of stuff. Interesting protocols, satellites, airplanes, DECT, you name it, building automation, there's lots of stuff to look at. We'll upload the slides later on, so you can have a look at all the links also from the previous slide and this stuff. Hack on your heart's content. There's a lot of stuff to be discovered, and it's not that hard, really. Possible standalone applications. Now, really, I mean, this thing, it's a multi-role SDR badge. So, I mean, it has the battery. It can run standalone. Use that. Use the processing power you have on there. Do something which is not running on your laptop. Use the power and have something, you know, which you just turn on, it just works. You don't have to boot anything. You have to start up a new radio and have stuff like that, which is not working potentially because some software update was going on. And there's a lot of stuff to do. put stuff onto the SD card, sampling onto the SD card, transmitting from the SD card, self-made home automation. Maybe you have some power sockets you want to turn on or off. You can do that with the radio, no problem. Indoor localization. Also, the USB ports. No one has done something with the USB ports yet, but I mean, they support the host mode. So you can take a USB stick, plug it into one socket with an USB on-to-go adapter, take the radio, plug it into your computer, have a look at what's going on over USB, maybe a USB firewall, USB sniffer, intercepting stuff. You might know the, how's it called again? Travis Goodspeed has a nice one. The Face Dancer, which does that also. No, you can do it with the radio too, for sure. Then, getting a radio. As I said before, there's one of our prototype manufacturers which has agreed to manufacture radios again, if you ask them. It's Dietz Elektronik Manufaktur. I propose that if you really want to get a radio, get together on the mailing list. We now have a mailing list, will be on the next slide. Get some group orders going. We'll provide a data set of complete data set which you can give to them so they can manufacture the stuff. But really, you're on your own, probably sourcing the parts, getting the deal with them going. Really, we're not in the business of selling stuff, and that's probably not going to change. Then, last slide. Mailing list. There's no mailing list. It took us half a year to do it, but we finally have it. Get on it, especially if you want to get a radio. We'll get to, we'll also be on there. We'll try to answer any questions you have. We'll support you in any way. GitHub, of course, get the radio, get the firmware from there. The wiki hasn't been that active lately, but really, if you want to document something, go there. I think lots of people are still looking onto that thing. And the Radio Badge Twitter account, you can get any news from there. I think we had some nice responses just before Congress for the launch list and the other actual new apps we have for the radio. Then at the assembly, down at Hall 3, we have the flash station. You can get the latest firmware from there. Just plug your radio in, have the joystick moved up at that point, and you will get the latest and greatest firmware. Take your radio to the lounge. I hope this is already live. Yesterday wasn't yet, but we're working on it hard, and I think Chris and Ans will be happy to have you with your radio there. Join the assembly. We'll be hacking on these slides. We'll be hacking on SD cards and stuff like that. And yes, half an hour after this talk, we'll have a little sale of SMA connectors, LEDs, and a few cases which are left. And SuperQ from Milliways, I think, has had this morning 8 RF kits left, and he's willing to sell them. He's at Milliways. Get to him if you want to have some of these. Thank you very much.
Thanks a lot, Zach and Schneider. So we have 10 minutes left for questions. If you need to get out already, please be quiet. And if you can stay, please stay. Do we have questions from the internet? A few, all right. If you have questions here in the audience, please come to the microphones. They are always like in the aisles. And we take the first question from the internet, please.
The first question from Anon and Tatzelbrum. They were wondering what tools were used to dimension the antenna.
Okay, pieces of copper. No, really, the antenna is a reference design from, I'm not sure, I think TI actually. And we had it on the first prototype. It was way off. And what we did, we took little pieces of copper, we soldered them on, tried to change the dimensions a little bit to make it, to tune it to the right frequency. And then we measured these dimensions and put it into the final batch. And, well, it's off a little bit. That's what we did.
Trial and error, basically. Hello? Test? It was trial and error, basically.
Okay, one question from the microphone 3.
Hello. You mentioned that you found some bugs in the hardware and you published the plans. Did you adjust them after you found them?
That's a good question. No, we did not. So the thing is, I'm working in hardware a little bit, also professionally, and I tend to don't touch it. It's working more or less right now, and it's working pretty well, given what time we developed that in. And the bugs we found are minor, I would say. If you want to change these, you'll have to file a pull request, change them. But be aware that if you change anything on hardware and you produce that stuff in mass, that's tricky. You need to do prototypes, really. Smallest change, you need to do prototype. That's my opinion.
Thanks. One question from the internet, please.
A question from Hector. At which power level does the FM sender work, or the sender in general?
We can put out a roughly plus 10 dBm. So that's, what is it? Yeah, 10 dBm. But we don't reach that always. It's a little bit dependent on the frequency. And the FM transmitter has all the gains available to you. So you can tune up the TX gain and activate the external amplifier if you want to put out a little bit more power. Be aware, if you turn on the external amplifier, or not the external, like the extra amplifier, and you also turn up the TX gain a lot, you'll get a lot of harmonics. That's like it is, but yeah, we don't care about that too much.
Okay, now microphone 4, please. Oh, that's no question. Okay, then 3, please.
Hello. So it's more than a feature request. So it would be cool to have a generator, code generator for GNU Radio. So you can build a flow chart there, flow diagram, and produce a Python code, and do the same with the radio project to produce code straight to the CPU of radio.
With a flow graph, it's not on our to-do list, I would say. Sounds nice, also really hard.
Yeah.
Honestly, I have no idea how to do that right now. So it's not on our plans. If you have plans to do it, and then submit a pull request, we would be happy to merge it, but I don't see that happening right now.
Okay. Thanks for providing the pull request. So one question from the Signal Angel.
Tetzelbrum is wondering, is there a hardware errata file somewhere? And if not, could you put it there on GitHub?
Yes, we've just presented it to you. No, seriously, we found out a few of these bugs 2 days ago while checking some things again and making sure of a few assumptions we always had. And at the moment, it's this presentation, but it's a good point, and we'll put up a wiki page of this. Yes.
Okay, great. We still have 5 minutes, so we can relay a few more questions from the internet. Thank you.
Also from Tatzelbrum, could you give some pointers toward software tools and resources to write apps and firmware for the radio?
I mean, the software tools is just a compiler, and you can look at the GitHub code that is there. There's no magic documentation anywhere. I'm sorry we didn't have the time, but I think the code is not too hard to understand if you just look at the code that is already there, and that's all the help you get at the moment. I'm sorry.
One more?
Yes. So, also wondering, how important are the metal cans around the sensitive circuits with regard to the RF parts? Because some people didn't get them at the CCC camp.
The metal cages?
How important? Well, they're quite important for mechanical protection, really. And we did measurements regarding RF performance, and it's not that much better with the shields on. But we're very happy if people have shields on, because that will protect the things from mechanical damage. I mean, they give a lot better results if you have some strong transmitter next to your badge, and that might be a motor, for example.
Or your laptop's Wi-Fi.
Yes, anything which has something which creates a spark or has a powerful transmitter in it, that will radiate into the radio, and you will get that in your received data. But if you don't have that, there's not too much additional benefits from having the shields on.
Do you have another one?
Yes, there was some discussion about the preferred design tools for hardware. And would you recommend KeyCard or basically, yes? What's the preferred design tool for the community, would you say?
KiCad, for sure. We did it in, I would have liked to do it in KiCad, really. The problem was that we didn't have time to get some people into KiCad at that point. That's including me. And we had to really spit this thing out in a hurry. And so we had to go back to Eagle because everyone in the team was fine with Eagle and knew how to do that stuff. And that's the only way we were able to get this thing done in time. The HackerF original files are in KiCad, and I think that's really good. And it would have been nice to have the radio in KiCad too, but that's sadly not the case.
Thank you. And microphone 7, please.
I just wanted to ask if you have any information about external amplifiers.
Any information? The only information I can give you is, there's two things. Take a look at the latest video from Michael Osman. He's talking about transmitting and also amplifiers. And the second one is, put a filter after that thing. If you amplify your signal a lot, you will have spurs at places where you don't expect them, especially if you amplify stuff. And you have to check with a spectrum analyzer. You really should, if you put an external amplifier on there, and you should put filters on there to limit the amplifier to the region where you want to amplify something. Unless your amplifier has some internal filter characteristic already.
Thanks.
Okay, and one last from the internet.
So Robinson wants to know, what is the maximum supported sample rate?
It's around 20 megasamples per second. You can go a little bit higher. And I'm talking about the radio in HackerF mode connected to a PC. You can get around 20 megasamples per second if you have a fast PC. Potentially even 1 or 2 more, but I think that depends on the USB stack and other factors. But really, you're limited by the bandwidth that USB can support at that point.
Okay, thanks a lot for those questions. Maybe somebody also can transcribe them somehow in some FAQ or something that people can read afterwards also. Do you have an FAQ already?
I think there's an FAQ on the wiki, yes.
Okay, so you can extend it and maybe put all the information you got today from the talk also in some written form so people can access it even easier. Thank you.
Thanks.
Thanks.
And yeah, thanks for this great project. If somebody of you has a radio at home and doesn't use it, please just donate it to somebody who can put it to better use, to your hackerspace or to some up-and-coming hackers or something, so the radios are not in the closet somewhere and getting dusty.